We are live. Okay, so here we go. Today's date is April 11th. We got 4, 11, 18. So, independent events. Stop talking. Everybody stop talking. Two events that don't affect each other. So the example I gave was, for instance, drawing a card and flipping a coin. They don't affect each other at all. You guys agree? If I flip the coin, it doesn't change the deck. If I draw a card, it doesn't change the coin. Independent, right? Dependent events, what do you think that would be? Two events that do affect each other, right? So two events that do affect each other. Okay? Example?
Pick two cards out of the deck.
Yeah, pick two cards. Pick two cards from a deck. So if you're going to pick two cards from a deck, but we're going to say with, the big key is this, without replacement, right? And I'm going to underline that, without replacement, because if you don't put the card back, then the deck is changed. You guys agree? I go from 52 cards to 51 cards, the deck has changed, okay? So conditional probability really is a dependent event, okay? Conditional probability is the probability of A slash B, and that's what the book likes to use, is this little symbol here, conditional probability, okay? They like that symbol because you've got to do event A, but B is affected. That's little symbols like B is affected by A. Does that make sense to you guys? Right? That's why they like this symbol, okay? You're going to do two events. You're going to pick a card. That's my first event. Okay, so my first event, probability, P, so it works like this. P, I got the probability of drawing a queen, right? That's my event A. So I got the probability of drawing a queen. But then I'm going to not replace the queen. So the probability of B is affected by A, isn't it? So then drawing a jack, the deck has changed, right? So that's why you see this symbol right here. Probability of A, and then B is affected by A. That's conditional probability, okay? Now, if it's independent, okay? If it's independent, right? Then an independent event is where you just multiply the probability. So, example, right? An example of this, okay? We're going to roll a dice and flip a coin, okay? Okay, we're going to roll an example. Write that down. We're going to roll a dice and flip a coin, okay? Obviously independent. When I flip the coin, the dice doesn't change. Okay, I'll say it again. When I flip the coin, the dice does not change. Or when I roll a dice, the coin doesn't become a three-headed dice, right?
That would be three-headed.
Right, exactly. Or a one-headed dice, right?
Yeah.
I mean, the card changed, right? I pull out a card, it definitely changed the deck. These are totally independent, right? So let's say we wanted probability. We want the probability of heads and a 4 on the dice. Okay, write that down. Here's my example. So I want P of this event, okay? So we're gonna roll a dice and flip a coin, and we're gonna win $1 million if we flip a head and roll a 4, okay? Okay. Now the question is, how good are your chances, okay? How good are your chances? So we know that the probability of A, how many 4s are there on a dice? How many 4s are there on a dice? How many 4s are on a dice?
1.
Out of how many? 6. So it's just 1 out of 6, right? Okay, probability B, what's the probability of flipping heads? How many heads are on a coin?
1.
Out of how many sides?
2.
Right? 1 out of 2. Does this make sense, everybody? Probability can be super hard, or it can just be so common sense if you think about it, okay? So then the way we get the probability of both is we multiply probability of A times the probability of B, right? So if they're independent, right, independent, then you're going to get the probability of A, which is 1 out of 6 times 1 out of 2, which is going to give you 1 out of 12. Now that's not real good chances, right? This is why gambling, real quick, and you're young, you're not 18 yet. Mr. Davies is going to tell you this flat out. I am a, yeah, just for fun, actually, yeah, I'll tell this real quick, okay? Oh yeah, I've done it like twice, right? Twice. And we did just for fun. So anyway, here's my suggestion to you as a grown-up, okay? Some of you will be grown-up. So if you want to try it, what I did, and I've only gone, I've done it twice just because friends want to do it. I bought a roll of quarters, $10. And I knew that at the end of the day, if I lost $10 and had a really good time at the casino, it's not that bad, right? So at the end of the day, well, we went up to, what's the place up by Manson, right? Whatever that place is, right? So within like an hour, my quarters were gone. Did I go and get more money? Heck no, I was smarter than that. They took my $10. If I'd gotten another $10, I'd get that $10, right? Because the odds were probably stacked against you, right? Now, my wife, though, however, it's a true story about my wife. She, ex-wife, doesn't really matter. Anyway, she got a little lucky on her first roll. So she had a $10 quarter, and the next thing you know, she was up to 20. She was on a roll, right? She got all the way up to 80, and I go, honey.
Then you quit while you're ahead.
Yes, yes. So I go, honey, we gotta go. You got $80 up. You start with $10. I go, you had a lucky night. Hallelujah. You had a great time. We're going home right now. She goes, no. And she got really mad. No, I'm not going home. She goes, I'm gonna win 160. I go, no, you're not gonna lose it all. And we had this argument finally, like, okay, whatever, yeah, I know better than to argue with a woman, so I go, okay. So, you know the rest of the story. Within an hour, her $80 went to zero. Bam! Just like that. Bam, right? And then I'm like, and then she's like, I need more money. I'm like, no, we're going home right now. No, I go, no. Yeah, God. So I'm like, okay, don't argue. So this time she took out another roll of quarters, and you know what happened to that. She lost that roll of quarters within 20 minutes. Bam, gone. And then she goes, okay, we'll get a car. I go, good idea, because you could have gone home with $80, and now you're going home with a negative 20. So my advice to you is, if you're going to gamble, do it for fun.
Take a certain amount of money, use that, and then leave.
And that's it. And enjoy the night, and realize that the odds. So in this game, now, really quick, back to this, because back to the game. So you watch. So the complement. This is what the casino gets. You have a 1 out of 12 chance to win, right? The casino has an 11 out of 12 chance to win, right? Because the complement has to make the whole thing, right? So you got a 1 out of 12 chance to win. The casino has an 11 out of 12 chance to win. That's why casinos are so bright and shiny and beautiful. They are making bank every day because every time you try, this is your probability. This is their probability. They're going to win, aren't they?
But how much do casinos cost to make and keep up?
Right.
All that, so eventually you're going to go out.
Exactly. Okay, you guys ready? Here we go. Turn the page. Shh. Okay. So, dependent events, right? So here's their symbol. Here's the symbol right here. And when you see this symbol, watch. When you see this symbol, it tells you that the event has already been changed, right? So when you're going to try and do event B is already affected by event A. Does that make sense? So when you see the symbol, you know that to do the second event, the first event has already changed the deck, right? So we know the probability of A and B is equal to the probability of A times their conditional probability. So let's check this out. Two events are dependent, okay? Then the probability. So example. First girl, second girl, okay? So it's an example 2 of our book, but we'll do it real quickly, okay? Okay, girls stand up. We'll do this real quickly. Girls stand up. Let's do our own example, okay? Okay, stand up. Girls stand up, okay? All girls stand up. Okay? All right?
I was waiting for
Okay? Now, how many girls we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We got 12 girls, right? 12 girls, right? So, stand up, Sasha. Stand up, okay? So, whoever's the tallest, sit down.
Sasha.
Okay, there you go. No, you only got one girl. Can be the tallest.
I'm the tallest.
There you go. You got to stand up. That's what she said. She said she's taller, so there you go. Okay, so now, so the probability of being the tallest was 1 out of 12, right? You win. But now, the next draw is this. Will the next tallest sit down? Sasha?
Yes.
So now, Sasha's was 1 out of 11. You see it's conditional probability, right? Okay. So if we do that, we can change this problem. Go ahead and sit down, girls. Okay. So our first draw was 1 out of 12 times our 1 out of 11, right? Did Fatima, okay, listen up, did Fatima affect the second thing? Of course she did, right? Because as soon as she was the tallest, then all of a sudden Sasha said, hey, I thought I was tall. And all of a sudden you were the tallest. But she had to sit down first, right? So you did change it, didn't you? So it was conditional because once you sit down, your probability changed, right? Okay, now, let's take a look at their example, and I'll be done real quick, okay? So example 1, independent or dependent. So you have 3 white golf balls and 2 yellow golf balls in a bag, right? So sometimes it helps to draw a picture. Some kids have a really hard time with this, okay? So draw a picture, okay? We have white, 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 yellow, yellow. So when you do probability, for a lot of kids, honestly, draw a picture. That's my suggestion to you, okay? Draw a picture, okay? So here's my bag. This is the top of my bag. Sorry, you guys. That's my bag. Okay? So you randomly select one golf ball to hit now, and another golf ball to place in your pocket, okay? So, if I pick out one golf ball, right, and put it in my pocket, does it change the bag? Yes. Is this conditional or independent? Okay, this is definitely conditional, okay? This is not dependent, this is conditional. Okay? What if you put it back in your pot, put it back in the bag? Then it would be independent, wouldn't it? Okay? Number 2. Okay, almost done. Your friend writes a phone number down on a piece of paper, but the last 3 numbers get smudged after being put in your pocket all day. You decide to randomly choose numbers for each of the 3 digits, okay? So, use a sample space, okay? Use a sample space to determine whether guessing the first digit correctly and the second digit are independent events, okay? Now, are these independent or dependent, okay? So you're going to write a number down. You're going to try it on your phone. It doesn't work. Would you pick that number again? If you were me, you would, because I don't have a very good memory. But hopefully you're smart enough that you'd say, no, I wouldn't use that number again. So they would be dependent, right? Unless you forget. If you're me, if you forget, it could be independent because I forgot the numbers I picked, right? Okay, so I'm going to stop there and have you guys